And here's our product demo. So before we start, I just want to go through a little bit on the architectures of VeilProtocol. So VeilProtocol contains three main components: the client, the program, and the indexers. The client and indexers only live on the user's local machine, and the program is deployed on Solana. So the clients provide like tools, UI for users to import or create a key, including normal Solana key pair, which is used to sign transaction. And from the user's private key, we derive three main key for transaction encryption: the spending key for spending UTXO or unspent transaction output. Essentially, it's a vault money that you own. The viewing key for viewing transaction info, which normally including the receiver and the sender. And the deposit key, which is used when users want to deposit their asset into our protocol or shield or like shielding the asset from outsider. The indexer act as a scanner, a separate worker running to scan event emitting from our program, which including like ciphertext. So it will try to decrypt those ciphertexts. If they're able to decrypt it, which means they own the users own that asset, so it will be stored in a local database from which the client can then query essentially like the available balance. So Veil program acts as a single vault which hold all the asset, and then in order to spend the asset, users just need to provide it the zk proof of ownership, and it's Veil program job to verify those proof without actually knowing the transaction detail. So here's our basic user deposit flow. So when users want to deposit some asset, it will ask the client to send some instruction data into our Veil program, which contains ciphertext and commitment. So commitment is basically like a encoding version of all the transaction data, which will be added into our Merkle tree. So the client will have a Merkle tree, and the program side will also have a Merkle tree, and the protocol will make sure that both of the Merkle trees are sync. So the actual Merkle tree leaf is encoded, so outsider cannot trace or cannot derive any information from those leaf, only when the ciphertext is emitted through the event, and our indexer will scan for those logs and then use our viewing key, deposit key to decrypt those transaction info. So if we are successfully decrypt those info, which prove that those UTXO are our and will store in our local database. So for transfer, since all the available UTXO is stored on our local database, the users can then query for those, essentially like querying their available shield balance, and then they can choose what to spend, and then ask the Veil client to create the ciphertext, the new commitments, or like the new commitments, or basically indicate the new balance of both the sender and the receiver, and the zk proof that they own all this UTXO. So Veil program will verify it and emit the event, including all the ciphertext. Oh, missing the commitment. Also, the commitment is also being emitted. So both sides will scan for those commitment and update their Merkle tree, and the ciphertext is for users to decrypt. So if they successfully decrypt, it will store in the local database as a available asset. And so withdrawal is essentially just the same, but only on the one user side, the withdrawal. So they still need to provide the proof that they own those UTXO or those assets, and then the program will verify it. And if they're not withdrawing all the balance out, which means they still have some shielded asset left, then it will also include a ciphertext and commitment for that. And then our indexers scan again to update the shielded balance. So yeah, that's enough for the architectures talk. I will go right into our web demo. So we built a simple web for our MVP, which including three main features: the deposit, the transfer, and the withdraw features. So right now it's connected on Phantom wallet. As you can see, I already log in to my Phantom wallet. So the price is still a mock API, but we can add it the real price later on. Right now we are working on the DevNet. So you can see the shield token. The shield token is all the token that we deposit on our VeilProtocol. And this is basically the total of all the UTXO stored on our local machine, while the unshielded token is essentially the normal wallet balance. It's fetched from Phantom. Okay, so let's try to shield some asset. Oh, and a quick note, for this demo we already generate some zk proof for the stuff we're gonna spend later, because right now the proof generation process took like 9 to 10 minutes. So we will work on that. We have some solution to optimizing it, mainly using recursive and stuff, but that is outside of our 4-week sprint. We will try to do it later on. So I'll try to shield 5 token, 5 Solana, and let's so we'll wait for the client to process, create a ciphertext and stuff, create the instruction data to send to Veil program. Just need to sign this. We're using the local DevNet, so there's plenty of airdrop for testing. We'll wait again for them to sign in the transaction. Yep. As you can see, 5 token. 105 token. So plus the 5 token we just showed, and it's already reduced here. So essentially what happened is the user sent 5 token into Veil program own account. So everything is gonna be stored in a single account, every asset, and then users, in order to let's say want to transfer to some. Okay, we already have a demo wallet here. Let's send 5 token. Again, we already generate the zk proof for this 5 token already, so let's run it. So right now our way to pick like which UTXO is being chosen to spend, right? So right now we're just doing by a queue, so first in, first out. So essentially what UTXO is that it's a list of vault that the user owns. So we're just gonna pick the first one, and then if the amount is not enough for the amount that we want to transfer, we'll pick the next one, and then and again. But in the future, we'll add features where users can pick what UTXO they want to spend. As you can see, we have successfully sent the 5 shield token. And so for the final features, let's try and use unshield. So let's fetch back 5 token. Again, we already generate the ZK proof for this, so it will be much faster right now, because well, in zero knowledge proof, the verification process took like very fast, like only a few milliseconds, but the proof generation took like, if not optimized, it even can reach to like 15 minutes. So yeah, as you can see, we have our 50 token back as unshielded token and 95 token as shielded token. So that's it for our product demo. Thank you for watching. And if you have any question, don't hesitate to contact us on all of our social. Thank you.